Today we will tackle about the definition, example, nomenclature, properties, synthesis, and reactivity of ketones and carboxylic acid. We will first discuss the ketones. A ketone is an organic compound that has a carbon atom with a double bond to an oxygen atom, or this is called carbonyl functional group. This carbon atom must also have single bonds to two or other carbon atoms. A ketone can be produced by oxidating a secondary alcohol. It will also show a strong peak between 1690 and 1715 cm one using the infrared spectroscopy.
Example of ketones in chemistry. A ketone is a functional group with a structure R2C equals O, where R can be variety of carbon-containing substituent. Ketones contain a carbonyl group, a carbon-oxygen double bond. The simplest ketone is acetone. R equals methyl with the formula CH3COCH3. Many ketones are great of importance in biology and industry. Examples include many sugar, many steroids, testosterone, and the solvent acetone. What are the uses of ketones? They are mostly widely used as solvent, especially in industry manufacturing, explosive, lacquers, paints, and textiles. Ketones are also used in tanning as preservatives and hydraulic fluids. The most important ketone is acetone, a liquid with a sweetish odor. The nomenclature of ketones. The International Union of Pure and Applied Chemistry, or IUPAC, name a ketone is derived by selecting as the parent the longest chain of the carbon atom that contains the carboxylic group. The parent chain is numbered by the end that gives the carbonyl carbon the smaller number. The suffix "e" of the parent alkane is changed to 1 to show that compound is ketone. For example, CH3, CH2, CO, CH2, CH, parentheses, CH3, close parentheses, 2, is named 5-methyl and 3-hexanone. The longest chain contains 6 carbon atoms, and numbering of the carbon must begin at the end that gives the smaller number to the carbon. The carboxylic group is on carbon 3, and the methyl group is on carbon 5. In cyclic ketones, numbering of the atoms of the ring begins with a carbon as number 1. Common names for ketone are derived by naming each carbon group bonded to carbon a separate word followed by the word ketone. The simplest ketone, CH3COCH3, whose IUPA name is 2-propanone, is almost always called by its common name, acetone, which is derived from the fact that it was first prepared by heating the calcium salt of the acetic acid. The physical properties of ketone. In many of the reactions, ketones and aldehydes are the same, as both of them have the carbonyl function group. In the most important types of reaction, such as oxidation, they differ greatly. Ketones resist the oxidation, whereas aldehydes are readily oxidize the carboxylic acid. Aldehydes are among the organic compounds which are easily oxidized. The ease of oxidation helps in their identification. The reaction of ketones. Ketones are highly reactive, although less so more than aldehydes, to which they are closely related. Much of their chemical activity results from the nature of the carbonyl group. Ketones readily undergo a wide variety of chemical reactions. A major reason is that carbonyl group is highly polar. It has an uneven distribution of electrons. This gives the carbon atom a partial positive charge, making it susceptible to attack by nucleophiles, which are species attracted to positively charged centers. Secondary alcohols are easily oxidized to ketones. The reaction can be halted at the ketone stage because ketones are generally resistant to further oxidation. Oxidation of secondary alcohol to a ketone can be accomplished by many oxidizing agents, most often chromic acid, pyridinium chlorochromate, potassium permanganate, or manganese dioxide, with a few exemptions such as oxidative cleavage of cyclohexane C6H10O to adipic acid HO2C, a compound used to make nylon 6. The oxidation of ketones is not scientifically useful. The treatment of an aromatic hydrocarbon with an acylic halide or aldehyde in the presence of the catalyst composed of Lewis acid, most often aluminum chloride, gives an alt or dial ketone, where R represents an aromatic ring. This reaction is known as Friedel-Crafts acylation. So as you can see, that is the reaction of ketones. Below of it is the Friedel-Crafts acylation. Nitriles or RCN react with a Grignard reagent to produce ketone. Following hydrolysis, nitriles plus RMGX ketones possessing hydrogens can often be made to undergo aldol reaction, also called aldol condensation, by the use of the certain techniques. The reaction is often used to close rings, in which case one carbon provides the carbon group and another provides the carbon with an A hydrogen. An example is that a synthesis of two cyclones. In this example, the aldol product undergoes loss of H2O to give an A unsaturated ketone. So below of it is the example of synthesis of two cyclohexane. So as you can see in this example, the aldol product undergo loss. The synthesis of ketone. Aldehydes and ketones are synthesized by the oxidation of various kinds of alcohol. The definition which are used in inorganic chemistry involving the gain or loss of electron, or the increase or decrease in oxidation numbers are not very useful in organic chemistry. In organic chemistry, although changes in electron are important, oxidation and reduction is more readily observed from the changes in the number of hydrogen or oxygen atoms. The definitions are as follows. oxidation, loss of hydrogen, gain in oxygen, or loss of electron. Reduction, gain of hydrogen, loss of oxygen, or gain of electrons. The oxidation of secondary alcohol yields ketone in the oxidation of alcohol. The oxidizing agent, usually represented by the zero, removes the hydrogen and electrons from the alcohol. The reducing agent, the zero in the oxidizing agent, is some unspecified oxygen atom which reacts with the hydrogen atoms to form water. The oxidation of secondary alcohol leads to the formation of ketone. This relationship should be clear if you carefully consider the position of OH group in secondary alcohol and the position of the carbo group in ketone. Both functional groups are not in terminal carbon. On the other hand, a primary alcohol and the aldehyde are on the terminal carbon.
Next one is the carboxylic acid. So what is the carboxylic acid? It is an organic compound containing a carboxyl functional group. They occur widely in nature and also synthetically manufactured by the humans. Carboxylic acids are also the most important functional group that present the C equals O. This type of organic compounds can be obtained by different routes. Some carboxylic acid, such as citric acid, lactic acid, or fumaric acid, are produced by fermentation. Most of this type of carboxylic acid are applied in the food industry. The next one is the example of carboxylic acid. So this is the describing of nomenclature of carbolic acid as per IUPAC guidelines are provided. So the left side are the trivial name and formula, and the right side is the IUPAC name of the carboxylic acid. For example, this formic acid, which has the formula of HCOOH, and the IUPAC name of this is the methanoic acid. Next is the uses of carboxylic acid. The uses of carboxylic acid is the fatty acids. This is the essential to human beings that are made up of carboxylic acids. For example, the omega-6 and omega-3 fatty acids. And also the higher fatty acids are also used in the manufacture of soaps. Carboxylic acid also can be used in the production of soft drinks, and many other food products involve the use of many carboxylic acid. Also, the manufacture of rubber involves the use of acetic acid as a coagulant. The carboxylic acid have numerous applications in the rubber, textile, and leather industries. The production of many polymers involves also the use of compounds containing the carboxylic functional group. Next one is the nomenclature of carboxylic acid. So, select the longest carbon chain containing the carboxyl group. Next is drop the final E from the hydrocarbon name. The third one is add the suffix OIC acid. And the number the carbon of parent chain starting with the carboxylic acid. Always remember that carboxylic group is always in the beginning of the carbon chain. Lastly is the name other group attached to parent chain as usual. So this is the examples of nomenclature in the carboxylic acid. Properties of carboxylic acid. This is important classes of organic compounds known as alcohols, phenols, ethers, amines, and halides consist of alkyl or aryl groups bonded to hydroxyl, alkoxyl, amino, and halo substituent respectively. If these same functional groups are attached to an acyl group, their properties are substantially changed. They are designated as carboxylic acid derivatives. The second to the last that we will tackle today is the synthesis of carboxylic acid. The oxidation of primary alcohols is a common method for the synthesis of carboxylic acids, the RCH2OH to RCOOH. This requires a strong oxidizing agent, or the most common being chromic acid, the potassium permanganate or the KMNO4, and the nitric acid, which is the HNO3. Lastly is the reactivity of carboxylic acid. Among the carboxylic acid derivatives, carboxylate groups are the least reactive towards the nucleophilic acyl substitution, followed by amides, then carboxylic esters and carboxylic acid, esters, and finally acyl phosphates, which are the most reactive among the biologically relevant acyl groups. And that's the end of our report. Thank you.